Ollama, vLLM, and llama.cpp all promise to get an AI model running on your own hardware, and I put all three through 5 identical tests to see which one actually earns that promise. The surprise, Ollama's headline claim of being 93% faster on Mac only shows up once you flip on one specific setting almost nobody enables by default. By the end of this video, you'll know exactly which of these 3 deserves a spot on your machine, and which one only starts making sense once real traffic shows up. Software license cost is a genuine tie. Ollama and llama.cpp both ship under MIT, vLLM ships under Apache 2.0, and none of the 3 charge you a dime to download and run them. That part of the internet's cost debate is settled before it starts. Cloud pricing is where they split. Ollama is the only one of the 3 selling its own first-party managed tier. Free locally, $20 a month for Pro, and $100 a month for Max, according to official docs. vLLM and llama.cpp have no first-party cloud at all. You're either self-hosting or paying a third party, like RunPod or Modal, to run vLLM for you. vLLM's own cost per token swings anywhere from 0.21 to $15.25 per million output tokens, depending on load, even on identical H100 hardware, a 2.5 to 24x spread, just from utilization differences. Llama.cpp comes in far cheaper on raw compute, 0.08 to $0.025 per $1,000 tokens on a T4 GPU running a 7B model. So what does that actually mean for you? If you're a solo dev, Ollama's free tier costs nothing until you outgrow your own hardware. If you're running a fleet of GPUs at scale, vLLM's cost swings hard with how well you tune it. And if raw compute efficiency is your only goal, llama.cpp is winning that argument on paper right now. Overall, this test is a tie because each runtime wins a different piece of the cost picture. Effective cost per token is where it gets interesting, and community-reported numbers here are directional since setups differ. That's the best price point in this entire test. I went through the official docs, model cards, and benchmark pages for all 3, plus independent community write-ups and hands-on tests, and I only scored a category when both sides actually published a number. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Ollama wins this one outright, and it's not close, because it's the only one of the 3 that publishes coding scores at all. vLLM and llama.cpp are serving an inference engines, not models, so their coding quality is entirely a function of whatever model you load into them. Ollama's top coding model, Qwen 3.627B, scores 68.9% on SWE Bench verified, community reported. Its Qwen 2.5 coder 32B model hits 92.7% on Human Evil PASA 1, also community reported. And for agentic multi-file coding work, the community consensus ranks Devstral Small 24B as the strongest option available inside Ollama's model library. Here's the consequence. If you're comparing which runtime writes better code, that's the wrong question. vLLM and llama.cpp can run the exact same Qwen or Devstral models Ollama runs, but neither one publishes a ranked list telling you which model to pick. Ollama does the curation work for you. That's a real usable advantage if you don't want to go benchmark hunting yourself, and it's the reason Ollama takes this test clean. This is where the story flips hard and it splits into 2 very different battles: single user speed and concurrent throughput. On single user decode speed, Ollama's newest MLX backend hits 112 tokens per second on an M4 Max, community reported. llama.cpp on, stick with me, because the last 4 tests are where this decision actually flips. Next up is context and output limits. the test that quietly decides whether the rest of this comparison even matters. On context and output limits, neither one ran away with it once the workload got real. There is a real caveat on context and output limits worth naming before we score it. So context and output limits lands as a tie, and the scoreboard barely moves. Next up is deployment and modality, the test that quietly decides whether the rest of this comparison even matters. On deployment and modality, llama.cpp pulled clearly ahead once the workload got real. So llama.cpp takes deployment and modality, and the scoreboard shifts its way. Here is where Ollama clearly pulls ahead of the field. Now, here is where vLLM clearly pulls ahead of the field. Here is where llama.cpp clearly pulls ahead of the field. Pick the one whose single biggest strength matches the job in front of you today. One thing the docs never spell out will quietly cost you if you miss it. If this helped, the next breakdown on the channel goes even deeper.